Okay, hello. Um, I start demonstration. In the previous lecture, we consider we consider. Do you hear me? Okay, you hear. We consider Cassarage algorithm, and we find strong connected components in it in graph. So let um, create function id id where means number of CSS in Cassarage. In Cassarage's algorithm. So uh, so note for you, if we consider some edge AB, then ID A less or equal than ID B. Why is it true? Um, First case, I and B located in the same component. That means ID A is equal to ID B. Other case, you have edge AB. So in this case, ID A less than ID B. Why? Why is it true? We consider Cassarage algorithm, and we do topological sort. We reverse edges, and we um, launch the FS. So if it's not true, we start the FS from A from B, and we mm, from A from we reverse edge, so we get AB edge, and in this case we launch the FS from this component. We launch the FS and get that ID B less than ID A. We get that just get into this component if ID A greater than ID B, then we launch the FS, and then we launch the FS from this component, and we get into this component because сейчас, ну, как там было? do topological sort, if we go сейчас go the first on reversed edge. So this statement, so this condition must be have this sign. So the problem, the problem given a SAT, given a token F, given a token F, for example, X and Y, not A and B, suppose Y, not Y and not B. So we need to find token F. Token F. We need to find a truth assignment. To this variables. So that makes the whole formula phi true. How to do it? This problem called 2SAT, satisfiability. So how to solve this task using graph and DFS? No, first of all we create a graph. Create a graph. In this graph, in which the whole the verticals, not verticals, vertices are all the variables. So we create vertices x, y, a, b, and x, нет, for example, x, y, not a, b, and not y, and not b. How to code this? So if we consider AB, for example, it can be write as not B, then A, or not A, then B. Just to prove this, just do the brute force. Do the brute force of this formula, of this and this formula. This is the same. So we need to, so if there is a h between, if there is a and b, we just create h from b to a, from b to a, and from a to b, from not a to b. So we do this for each bracket. By the way, we create not x. Is it neat? I think it doesn't need. So if we have this vertices in our formula, we just create edge. So we do this for each bracket, and get some graph. And so to prove that this works, we need to proof statement phi is satisfiable, satisfiable. That means there exists a set that phi, that in which phi is true, is equivalent to IDP, not equal IDP in this graph. So we try to prove this using contradiction. By the contradiction. Exist P, здесь для любого, for each P. That means exist, we reverse this condition, exist P, ID P equal to IDP, ID not P. So we have P and P. We have H between them. So we get a contradiction because P and P and not P can't be one, because if you have if we have one, we try to push it to this, to to uh, uh, to make this formula satisfiable, the whole formula. So we try to push it. By the way, DFS, we use DFS to push one to this, so we get contradiction because uh, we need to do these variables equal to 1. The next for IDP not equal to IDP, this means давайте let consider two cases when IDP less than ID not P. Почему я постоянно пишу? Ага. Сейчас. Two cases. IDP less than ID not P. So it P must equal to null, otherwise P equal to 1. So show that is show we need to show that it's a satisfiable set let's use again contradiction, proof by contradiction. Let is not. Hence there is exist x and or y that equal to null. So this means x equal to null and y equal to null. Hence ID x less than ID not x, and ID y, ID y less than ID not y. So we need to notice that if there exists h x y, because we construct our graph in such way. If we have x or y, we just create edge. So So 2h is not need we need 2h from for improvement and for solution 2, I think. Okay, and so we consider 2h and notice that id not x according to this if you have h is not equal is less than or equal id y less than id not y, and it less or equal than y, less or equal than id x. And there is contradiction because we have that id x less than id not x. So that means we prove this statement. So we need to do you understand this improvement? Have you questions? This proof. Okay, you understand? I think. So we consider how to apply Casaraggio algorithm for this problem. For example, this problem can be just the task about, for example, выключатели can be solved by using this. By using this, we just create some formula. That means выключатели, and so we solve some tasks using Casaraggio. By the way, the task about выключатели was the most difficult task to enter the ABI. In my year, no one thinking about this. No one, almost no one, solves this task. Euler. Next is Euler. Euler. What is Euler trail? In undirected graph, is open walk that uses only each edge exactly one time once. No, this can be Euler walk, for example, just in graph. Euler cycle. What is Euler cycle? It's the same, but it closed walk. Closed walk. No. If we have exactly the same graph, if there exists Euler trail, we need to create another edge from start vertical to end vertical. No, from end vertical to start vertical. There's two theorems about Euler cycle, how to find it. By the way, when I consider the tasks, a lot of tasks contain Euler cycle. No, on lead code. So it's very simple to find Euler cycle. Very simple to to implement. Let directed graph G we connected. What is weak? Weak means if we have let's do our let make our graph undirected. We just erase erase arrows from the edges from edges, and so in this way we get if we get that this graph is connected, that means directed graph we connected. So after removement or after deletion of isolated edges, isolated, not edges, isolated verticals, vertices, vertices. So hence in G exists Euler cycle equivalent to for each v index is equal to our degree. Income's edge, count of income's edge in vertical is equal to count of outgoing edges. For example, in this graph, is it true? Um, okay, and B for Euler trail in G there exist Euler trail equivalent to хотя бы два. Так, сейчас. Except two. Two. Maybe two. Except maybe two. Except maybe two verticals have in deck v. Нет, in deck v equal to out deck v. And except maybe two, there's ну, короче, for every vertical except maybe two in deck v is equal to out deck v. No, if you consider I already showed you how to intuitively understand this. We just create edge or delete edge between start and vertical in Euler trail we create. Okay, so так, we make a break for 5 minutes. let's continue. It's clear to see, by the way, it's clear to see for for the remaining two. Remaining two vertices. There's index. If we delete edge, index start vertical is equal to vertex is equal to outdeck, but we need to outdeck, but we need to add one, and the same for end vertical for vertex. Okay, there's one theorem, and to prove that theorem we need to prove second theorem. Наоборот, let G undirected graph and G is connected. So after deletion, of all isolated, we don't need isolated vertices, because if there is a graph, some graph, and there is isolated vertices, if there is some component that contains Euler cycle, this whole graph will be a Euler graph, because we don't have to visit these vertices because there is no edge between them. So we don't need isolated vertices. Так. So after deletion, we get another two Henses. I think G contain Euler cycle. Graph is Euler if it contains Euler cycle. So for everywhere, deck where is even. B, G contain Euler path. Если if we delete Euler not path, нет, path тоже надо. It calls path 2, but with Euler trail is equivalent to for everywhere there exists except just accept maybe two vertices. Dec v and for this verticals if it can be odd. So how to prove? Let's start with the T1 A. Okay, we need to prove that there is this Euler cycle there as in deck V equal to our deck V. It's obvious, I think. How to prove? We just if we consider, for example, some graph, and there is a Euler cycle exists. It means we in this Euler cycle we income to our we need to income to our vertical and outcome from our vertical. It means for every vertical it comes edge count of income edge is equal to count of outgoing edge. So in deck V is equal out deck V. B. There exists Euler trail. If there exists Euler trail, we just I already told that we just bleed edge, and if there exists Euler path, Euler trail, we just add between start and vertical edge. We use that in deck V is equal to deck V, then we erase edge and get that get this. So how to prove? Let's prove T2, I think. No. Just second. G contains Euler cycle. No, that's all obvious. All these statements are obvious, except T2 A. T2 вот этот переход. This so блин. Давайте докажем. T2 A. How to find area cycle when we all that all of this как Henses is all these senses will be obvious if we just prove this. How to find Euler cycle. Так, ну, construct proof. We just use the DFS without colors. Instead of them, we use the DFS with what? With colored edges. We if we consider graph, we can consider we need to paint all the verticals as white, gray, and black. So to don't get a recursive cycle, for example, recursive call. So another way to paint edges as gray. No, in this example, we need to paint it gray because we need to find Euler cycle. So we don't need to enter to the gray edges if we don't need to avoid recursion and avoid useless it's to avoid recursion we just paint all vertices are gray in this DFS. And сейчас давайте напишу. DFS, we use DFS without colors, without colors on vertices. I think I can write like that, but without colors on edges. No, implementation of this is just we don't need to contain colors. We just need to contain to reduce memory, to reduce to improve this. We just store pointers to the first stage. Pointers to the first edge that can iterate. Through all these edges. Through all edges. Не посещен, unvisited edges. We get some DFS. And how to and the question how to pass our graph to get Euler cycle. No, for example, PTR where Mm, just just a pointer, just a number, just a pointer to the first to the first unused edge. So how to pass? For example, we consider some unoriented or сейчас, блин, надо управлять стрелками. We consider some undirected graph. So we need to find Euler cycle. We do it like this. We create stack that we in which we will in which we will put the edges, choose random vertical and graph, and just walk. We just try to start the FS and suppose that the FS meet reach start vertex in this in the FS we push edges, and when we reach the end, we just write it to deck that is result deck. So this edge will be the first in our как? It can be vector or deck on vector. It doesn't matter. It's already result, but reversed result. So we push. We наоборот. We remove from stack our edges until we get some vertex that contains edges that we didn't visit. So we visit. So we visit another edge, 3, 4, for example, and so on. For example, we just we put towards stack h3, 6, and 6, 5, and so on, and we reach last vertical, last edge, and we just push we don't we don't meet any vertic vertices that contain edges, and we just push it, and we just put our our edge to result. So why is it algorithm is correct? Why is this path that will get in the result will be Euler cycle? To prove, we need to prove only that this algorithm ends in S. To prove this, only this, because как бы, and that's obvious because we visit all the when we pass our graph, we visit all the edges, and the last edge will be сейчас. The first edge will be the first in stack, and the last edge will be some when we if we visit all the edges in this graph, we reach last edge, we push it to our stack, and we visit all the edges. We visit all the edges, and we start from S. And in deck v is equal to out deck v. So if we visit the edge, it means if we visit the vertical, it means we always go out from this vertex. So this so the last the first vertical is S, and we need to all the edges we pass all the edges, and to perform this this equality, we need to visit last edge that income to S. Блин, ну, наверное, объяснил. Мне надо было write text on English. Ладно. Давайте, let me write some definitions. G is connected and unoriented graph. there is the edge. Here is bridge. If G without E, no, I mean G without E, it means just we delete some edge without graph from our graph, unconnected. For example, consider some graph. So this will be bridge. This will be bridge. Definition. Second definition. G connected. G connected unoriented graph. Hence, LAM is articulation point, or just con point. It means if we consider some graph, and in this graph we only this vertex will be con point. Why is it necessary? Because if you consider some network, which in client will be vertices and connection will be edge, we need to know that our network doesn't broke because it means we need to support bridges in this network, and we need to support cut points. We can support cut points easily. No, clients easily. Just for example, install strong computers, but sometimes in the companies, in our network, we don't want to contain bridges at all, so we create another edge to another connections to avoid disconnect at all. So let me create function right away. Mean equal to mean tin of v mean простите, mean tin at v and mean if we consider some graph, consider some tree, mean tin at v, if it is v, we start from some other graph, and we попадаем, enter in v, and we choose tin v if this contain no edges, and we choose this edge if we meet him, if we reach them. So it will be VU V sub 3, V sub 3, V belong to sub 3 of V, and VU reversed H. So minimum tin V W, and this statement we prove in the next seminar. H is bridge. Is equivalent to is it equivalent to red V, red 2 is equal to tin V, tin 2. We consider this example when this edge doesn't exist. And red and оно древесное. It's located in sub 3. Located in sub 3. V. Ну, V, например, for example. Okay. Could have questions about this? I think I bet explain this or what? Any questions about, for example, how to create graph or what in that problem? I think once again this algorithm we choose random how to find Euler cycle. We choose random vertical, we create stack, and we put from the stack we put edge we put edge when we reach some vertical that doesn't contain any edge that is unvisited, we just push edges to result while we until we don't reach the vertical that contain unused edges, and we again push this edge to the stack. Simple algorithm. Forgot to say that we use this to prove that S is no, we end in S. Mm-hmm. Okay, I think that's all. If you haven't questions. So see you next later.